Alright, 11.3b is still with probability distributions. Yesterday we learned how to find E of x, which was the expected value, and that was done by taking the prize or the value amount times the probability of that prize popping up. And now that we've seen a summation form, remember that's the summation symbol, including P of x. Now we're going to look at one including E of x. The variance, I think that's sigma, I can't remember. I'm not sure. I should have done my homework before I did this. The variance of a probability distribution is found by using the following formula. Again, this is the symbol for variance whenever you get into statistics, and it is the summation of x minus E of x squared times P of x. Alright, so first thing you do is x minus E of x, which is the value minus the expected value. Then you square it and you multiply it by the probability. It does look complex, but if we briefly discuss what's going on with the main part with notes, you should be able to kind of work your way through to it. The x minus E of x part, if you think about variance, it's how something varies, and so we're trying to get a measurement of how the values stray from what we expect, and this is why we subtract the expected value from x, which is your reward. So based off of what we'd expect, how far away is the prize away from what we'd expect it to be? So again, that's what tells us that. If we are getting $50 and the expected value is $1,000, this is going to be a big number. If we are getting $500 and the expected value is $600, it's not going to be as much. And so for each one of those prizes, you want to find out how much it goes away from what we'd expect. Okay? The second part, which is the second step of it really, is why are we squaring it? Well, if you remember, your expected value is what you would, actually I guess I was about to be redundant, but it's what you would expect to receive. It means that some of them are going to be higher than the expected value, some of those are going to be lower than the expected value, and we want to find out the sum of everything, and we don't want negatives throwing everything off. And so the way you get rid of a negative anytime is to square that number, because any number squared is going to be positive. And so yes, we start out by subtracting them, but then regardless of what that number is, we square it, because some of those are going to be lower than the expected value, some of those are going to be higher, but either way, once we square it, everybody's on an even playing field, and so now we get a number that we can actually use. The next thing you have to do, as we did in finding the expected value, is you must take that value that we found and multiply by the chances of it happening. Alright, so the probability of that was at the what we call that? We call that the relative frequency. What's the chances of this number actually occurring is going to be next. And so again, after finding that value, we have to factor in the probability, so we multiply by P of x, and it is mostly a task of organization in the end. As long as you understand the three key steps, again, we have to find the difference between what we have and what we expect. We have to square that number to make it positive, and then we have to multiply that number by the probability just like we did before. Then you're set up for the final step, which is pretty simple. Variance is typically a large number and it's rarely used in statistics. The value that's actually desired, the value that we actually want, is standard deviation, which is this symbol. Again, I think it's sigma, but I did not do my research. But yes, you should notice that variance is this value squared, which means you are correct in assuming that we find standard deviation by square rooting the variance. So the summary of this whole lesson is, if you can learn the process for variance, the standard deviation is just one step away. So the reason why I talked about variance is because to talk about standard deviation as a lesson, it would mean that I would have to give you that full formula, which is this. And I think it's x minus E of x squared minus or times P of x, all within a brace, all within a parentheses. I'm sorry, all underneath the square root, which when someone reads all that, this is intimidating enough. I would not focus on that part. Just remember that in the end you want to square root it, because that's how you actually find the standard deviation. Alright. What is the point of standard deviation? Again, the word deviate would be viewed as something straying away from something else. In this case, the bigger the value, the more spread out the numbers are. So if you get a standard deviation in one set of numbers versus that's higher than the standard deviation. Another set of numbers, it just kind of tells you which numbers are more spread out, which numbers are more compact. Again, in terms of overall information, it could be inconsistent versus consistent. I think the one that the book uses, if you look at chapter 11.3, is with stocks, and it has a stock that has a 80% chance of happening, 50% chance of happening, and they have the same expected value. And so in order to get a second read, a more overall read, they looked at the spread of the numbers, which is what, again, standard deviation is, and they found out which one was more consistent. Of course, if you're talking stocks, you want the one that's more consistent. But again, that's just pretty much what standard deviation is. So let's look at two examples of what you're going to see on your homework. I kept it in the table form, even though, again, it's kind of silly. But again, we are not in class, and so I did not want you to have to start a whole new process of understanding. I hope that you know how to find the expected value on this stuff. But if not, like I said, at least you're in an area where you should be at least somewhat familiar before we go. So I didn't want to change the question format around. I just wanted to make sure you understood the process of standard deviation. Now, of course, we need to find the expected value first. And so the way we found the expected value was by finding, I guess we could call it P of x right here. And that is where we had to first off add all these up. 3, that's 200. 5, so 505, I believe, is our total number of people. I think I'm going to do this on my calculator just to be sure. Yes, it is. So now we do 300 divided by 505, which is, again, and on this you do want to go 3 decimal points, so 0.594. 150 divided by 505 is 0.297. 50 divided by 505 is 0.099. And 5 divided by 505 is, that 9 would bump that up, so it would be 0.01. Now that we have the P of x, we want our E of x. And so I would just put that off to the side here and then do all the work, because again, hopefully as of yesterday you kind of got that work down, where we take 0.594 times 50 plus 0.297 times 400 plus 0.099 times 700 plus 0.01 times 1,000, which is an expected value of 270 or 228. Now, again, pay attention to this on the notes. We are still rounding this to 3 spots. We are still keeping this as a whole number because, again, expected value, we don't want to get too crazy yet. So once we get the expected value, we now start the variance process. Again, variance first, square root for your standard deviation. And so what we are going to do now is, again, this is where understanding helps. We want to do x minus E of x. And so we got 1, 2, 3, 4 numbers. And so I would just do, and you don't need to write everything in there, but that's your expected value. So 50 minus 228, which is negative 178. 400 minus 228, which is 172. 700 minus 228, which is 472. And 1000 minus 228, which is 772. The next thing we want to do is take that amount and square it. So we now do negative 178 squared. I'm sorry, I should have done that better. Negative 178 squared, which is a positive 31684. Now, I will tell you that when I initially did this, I did type in negative 178 squared, but you do want to use your common sense to recognize that that's always going to be positive, and just recognize that you typed it in a lazy way and ignore that positive, because as long as you do that, you should be fine. 172 squared is 29584. 472 squared is 222784. And then 772 squared is 595984. Okay. The next thing we want to do is take this amount times p of x. So in other words, now that we have the difference squared, which gives us a number, we want the chances of that happening. And so now we go back to our p of x chart, which is 0.594 times 31684, which is 18,820. And yes, we are going to keep those as whole numbers. So be sure to round the whole number up if necessary. And then 0.297 times 29584. Again, just be careful you're typing everything right. 8786. 0.099 times 222784 gives me 22056. And then 0.01 times 595,984. Just making sure. Which is 5960. Because remember, that's going to bump that up to a 0. Alright, so now that we have that, we want the sum of everything. And so now you take all these numbers, 18,820 plus 8786 plus 22056 plus 5960, and that gives us our variance of 55,622. And again, we don't want the variance, we want the standard deviation, which means we take the square root of that number, 55,622. Which is 235.8. This is the only number that you're really rounding. Outside of, again, the 3 digits here, and that's, I'm telling you this so you understand for the computer. 3 digits here, whole number, whole number, whole number, whole number, whole number, 1 digit. Alright, so when you square root, take the 10th, that should give you what you need there. But again, other than that, it's just a process of making sure you've got it. Now, I did everything following the table, but you're going to see when I do the second question, which is the last question for our notes, that it will work a little bit faster, because as you get used to it, it doesn't take as long as what I just showed you, because there are ways to forecast, which means look ahead in terms of what you're going to do. So I'm going to do this second question again, another set of prizes here. So you've got 2 sets of prizes, 2 sets of winners. Sorry you can't see it. And the question would be, what we're looking at is which of these prizes is more consistent, more compact. Notice you have more people winning, but it's only $25, and you have fewer people winning, but it's more money. So it's hard to kind of compare those things, because it's just really not as, the numbers get kind of crazy. So other than that, let's go ahead and look. That is 200, I believe, 201, which makes 601 our total. So 400 divided by 601. Again, this part's not going to speed up at all. 0.666, which is a lovely number. 150 divided by 601, which is, this 5 is going to bump up that 9, which therefore is going to make it 0.25. 50 divided by 601 is 0.083. And then 1 divided by 601 is 0.002. Okay. Again, now we want the expected value, which we should have learned how to do yesterday, which is where we take each of those probabilities times the prize, so 0.666 times 25 plus 0.25 times 300 plus 0.083 times 700 plus 0.002 times 1500, which is, again, round whole number, so 153. Okay, now this is where you're going to see me speed up a little bit, which after time you will speed up. We know we're going to do x to the ex. We know we're going to do x minus e to the x squared. And we know that we're going to take that number times the probability of that happening. And so you're going to see me actually cover these three all in one thing, which means I really won't even write that. So what I'm going to do here, again, as you get used to it, is 25 minus 153 equals. That belongs here, but I'm going to square that number, which belongs here, and then I'm going to take that times the probability 0.666, which is 10912. So as you can see, just by being sure that I know where the numbers are going, it helps me actually to fill out that chart a little bit faster. And since most people who want the standard deviation are not going to check your complete level of work, you can typically do it that way, although some statistics teachers will ask you to actually fill out everything, which is just a matter of time. But again, if you're just doing it for me here, you can do it this way. So 300 minus 153, which gives me that number from this chart, which we know we're going to square that number, and then we're going to multiply by the probability, which is 0.25, which gives me 5402. And then I'm going to do 700 minus 153 minus my expected value, which again would go here, but I'm going to square that number first, and then I'm going to multiply that number by the probability of that number occurring, which is 24,834. I am then going to take 1500 minus 153. I'm going to square that number, and then I'm going to multiply by 0.002, which is that's not smart. So multiply that by 1814409, which is 3629. So again, just in terms of overall time, we got there a lot faster. We didn't have to write as much. Well, writing makes it safer in terms of making mistakes in case you want to check your work. But once you get used to it, feel free to use that process. Remember that now we want the sum of that number. Two, 4, 8, 3, 4, 3, 6, 2, 9, 4, 4, 7, 7, 7. And then of course we want the square root of that number, which is 211.6. So looking at these two options, which one is more consistent, which is what that is asking you, and the more consistent one would be this one here, which would be the second one, because those numbers are more spread based off of the statistical reading. This is more or less spread, even though it's not, perfect, but it is less spread out than the other one. Anyway, this process is something you don't exactly memorize, but once you get a grasp, once you can do those three questions on your homework, and you can go through it on your own, then if you ever had to do it again later on down the line, you'd be able to do it because it's easy to remember once you have it in your brain. It is homework, not a quiz, so that if you do mess up, it doesn't just completely make you start all the way over. You do have 3 shots to get it right. Just make sure again that you're working to understand it, because that is the overall point of what we do. So I will talk to you tomorrow, and have a good day.